Welcome to tonight's Lightning Talk session, which streams live from the Hobido, not in the Hobido studio, but from a different studio. And if you have any questions, there's a panel after the talk where you can, just have a general conversation with us about all and everything which we do with the Lightning Talks tonight. Yeah, I don't need to talk about the conference. Tonight's Lightning Talks are 5 to 10 minutes. We have 5 speakers, but 6 Lightning Talks. So probably less than an hour. We'll see. As I mentioned, there's a Q&A panel. And these are tonight's Lightning Talk speakers. Jens Willer, Miroslav, Christopher, Killian, Søren, and I have a talk at the end again. So let's get started. I thought for starting the Lightning Talks and celebrating the 2 years, I say a bit about what we did in the last 2 years and have a little look out into the future. So today, Meeting C++ Online is, as you know it, and 2 years ago, we started this to explore things in the online world. And I'm kind of happy that today we do have almost 2,300 members. So when this group started, it was important as a playground to Meeting C++ to see what works. And from the beginning, I wanted to see if we could do more than talks, where just somebody gives a talk and we ask them some questions, and then that's it. So that is like how the fairs got born, and the event in May, which was speaking about C++, which I organized, which actually featured Lightning Talks, but was like a closed event, so you couldn't like submit Lightning Talks to it. Made kind of, for me, the knowledge available that we could do Lightning Talks, that we have the technical setup to do it, and so hence we do it now in the group. And I don't know how often we do it, but we'll do it often enough to have a few runs. So probably like twice a year. That would be good. And yeah, we started on Remo, and Remo had this particular feature that it has 2 states where a meetup runs in. And the first state is what you see. It's basically the break state where people sit on tables and talk, and then the software will, give you a countdown for 30 seconds, and then you will transition to the second mode where you see the talk. And I started wondering if we could utilize Remo for something else, which would not feature a talk, if we could utilize these tables for events. And that's how the fairs basically got born. And today is a job fair and also book and tool fair, which I'm going to talk about in a second. And last year, when I looked for a valid replacement for Remo, I got to see Hobido, and in the end, we're hosting on Hobido. And I can tell you already, the next year, the 3rd year, which we're now having, will also be on Hobido. And today and tomorrow are actually the last 2 events which are on the world contract. And our track record for the 2 years is pretty good. We have over 50 online events, but some of the things count as 2 events on Meetup, like the job fairs, and there's also the conferences from last and this year, and 2020, and meeting embedded, etc. So there's some things more, but that's a good run. And there's like in September we have 7 events. And I might even be looking into having currently we don't have an event in the last week, and maybe I have an event which is either in the last week in September or in the first week of October. I have to see if that works out. And the fairs are a great success, but they are also a lot of work. So I'm always looking for people wanting to join and be a company that employs people and is at the fair, has a conversation with the folks coming to the fair, and also receives for that effort a lot of CVs and resumes. And same as when you have like a tool, or when you have a book or an open source project which is related to C++, then you can have a table in the lounge for yourself on the book and tool fair, and basically have just folks come to your table and you can have a conversation about your tool or just anything else. And a quick overview on what I plan for the future. We do not have CPP-cast anymore, so I would like to offer an alternative, not like CPP-cast. I cannot replace CPP-cast, but I would like to make AMAs, and AMA stands for Ask Me Anything, in a recorded version available, that we meet with somebody in Hubilo and record the session in the rooms and simply have them, answer our questions and have the conversation then later on YouTube for everyone else to see. Tomorrow is something new. Community planning session is something where I got into when I was looking like, hey, how did we get started? What did I do 10 years ago? Because 10 years is now also for reading C++. And I kind of found a news entry about a community planning session, which we did at the beginning. And I was like, yeah, that's actually kind of a good idea. And so I thought, well, if that worked, 10 years ago, we have now the means to do that again. Just back then it was an IRC, now maybe not use IRC anymore. So it will be in Hubilo, kind of using today's event again. And of course, also something I found this year is, as me, C++ is my main job, that I want to use the tooling which I use for the user group and the user group itself, and some of the other things I built was reading C++, a bit more for promotion, to actually have also like this hiring in C++ event be more targeted towards people that actually want to hire folks and are recruiters or job leads or team leads in their companies, so that I can win them to have a starting cooperation on the job fair with me, C++. And then I want to mention sponsorships, which is something I would not have mentioned if I wouldn't have a sponsor for the first time in 2 years for the events next week. Next week is our regular meetup for September, with a talk from Johan van Stembroek, and which, by the way, he's here, so if he hangs around, maybe can ask him about that if you're interested in coroutines. But that also is sponsored by Undo, and I'm very happy to be able to get a little bit of funding through them for the things I do here. And so the next events. Next week we have the regular meeting, which I just mentioned, but we have also the book and tool fair, which is also, again, as you can see, attended by Undo, but also by the author of Beautiful C++, which is Guy for sure. And I'm not sure if Kate has time. Maybe Kate comes around, maybe not. We'll see. Then, yeah, the hiring in C++. I do that this time in LinkedIn, and that's also kind of a new experiment to see if that works and could be used and utilized as a platform. And the online C++ job fair will be in September, as I already mentioned. Tomorrow we have the community planning session, which is actually targeted at folks who want to organize or already organize things in the community, and, for example, user groups. And I currently think about starting a learning group where you can have a membership in and have weekly meetings where we then discuss things for C++. And I've just dug through my old teaching materials, which are all in German, and I have to kind of translate them to English and update them because they are quite old. And then I probably will provide some learning materials and provide the space for the debates, and also kind of make this a group which focuses on the needs of the ones which then are members, and will openly debate, like, where do we want to go with that. And that might be based on Patreon. I probably also will offer the billing through my website, because it's always the way, like, companies should pay that for their employers, for their employees. But we'll see. That's something which is going to be something new. And that is all the thoughts I have on those 2 years. And yes, I plan to carry the online events forward as long as it makes sense, as long as people are showing up. And I think that we will have a fabulous time in winter. And we probably always will have a fabulous time in winter, and the summers will be free, which is nice also for me. But now we see that September, October, and November, we will have a lot of events. And I hope to see you at one of those or many of those. Thank you for listening. All right. The next talk is by Miroslav. Let me quickly share slides, and you can start.
Thank you, Jens, for this opportunity to speak, to have a short talk. I start my timer just to not go beyond our limit. Hi, my name is Miroslav Boka, and in this short talk, I'd like to talk about single entry and single exit rule. Basically, for the software development, as we all know, we have different rules. We apply on our discipline of software development just to make our software more reliable, to keep it maintainable, and most of all readable. It is especially important when several people are working on the same code base. So one of those rules is single entry, single exit, and I had when I stumbled upon this, I got to have a closer look at the rule. So what is the rule all about? So this is the rule. More or less, it says that subprograms should have only a single entry and single exit point. So single entry and single exit only. And it is written like this in this safety norm, IEC. You can see it on screen in the part 7 and given section, which gives us some techniques and measures that we should apply to our software to make it safe and good for safety-related systems. As a reference, it quotes a structured design book, which is pretty old, 79, which in turn says that it is was highly influenced by the notes on structured programming wrote by Mr. Dijkstra in 1970. So the idea back then was to simplify the flow of the program, because back then the typical programming languages used were assembler, Fortran, COBOL. There was no C, there was no C++. And in those languages, especially in assembler and Fortran, it is easy to jump all over the place. In assembler, it is clear. But even in Fortran, we can jump into a subroutine procedure and start it not from the beginning, but a little bit later. It is possible. Of course, we can jump out of it also earlier. So that led to the code, which was kind of spaghetti. And sooner or later, people realized we have to do something about it, because the code becomes unmaintainable and hard to understand. So that was the proposal to solve this problem, or to address this problem. And Mr. Dijkstra wrote quite a lot about this, not only about the structure of programming, but also about the go-to in general. So he said that it's not a good idea to use. Okay, where is the rules used? So as mentioned already, these IEC standards say that explicitly. MISRA took this standard from EIC, and it says with a little bit different form. As you can see, it is function should have a single point of exit at the end. It is clear because they adapted it to the modern languages, so in 90s. So when we start a procedure, we start always from the beginning. So we are not jumping to the middle of it, but we can still jump out of it quite easily. In Google style guide, it is not mentioned at all. So it is left to the user. Autos are explicitly say that we are permitted to jump out before at different places. And ISO C++ coding guidance go one step forward, saying that just we should not insist on applying this rule. So they are just a bit more on liberal side. And so just briefly, what the rule, how the rule looks in a practice. On the left side, on the right side, we see the same code, but on the left side, we have this rule implemented. On the right side, not. On the left side, in both sides, there are just three conditions to do something, and at three different situations when return different error code when conditions are not met. So it looks like this, more or less. And but we have one single exit point. On the other side, we can just check the conditions at the beginning and exit early, returning the appropriate error code, and only when all conditions are met, we are doing our stuff. So this is more or less the difference in a style. And yeah, so for my personal point of view, I prefer the second version because it gives me a bit more easier to understand code. And if we compare different the advantages and disadvantages of this style, I sorted them out into three categories: readability, resources, and debugging. Readability I made in bold because I think this is something which is for me personally extremely important. So on the single exit, single entry and exit rule, as we could see before, it pretty quickly gets hard to understand when we have a lot of nesting inside. Then it gets a bit problematic. On the other side, when we are a bit relaxed about this and we can exit early, then it makes our code easier to read, and which was not visible, but it's worth mentioning. It frees our mental resources when we know that at some point in the code, from this moment on, we can focus on our task because the preconditions are already solved or taken care of. So that's one thing. On the other side, it's more, sometimes people are saying this more about resources. So they are in using the rule, we can ensure that resources are freed at one place. And the rule is not that on the other side, it could have been a problem before, but using C++ and resource allocation is initialization, we can pretty nice get around it. So even if we exit early and we allocated something, we may make the code so that we don't lose resources. I've heard also opinion that then debugging is easy regarding single entry, single exit, because we can set there's one breakpoint somewhere at the end, and we know what is, when we stop there, we know what was before, when we can inspect the previous variable. On the other side, we have to take several breakpoints. So that's the comparison. All the links to standards I mentioned before, I collected in one place, and here are the links if later we are going to share these slides. And also I collected some links regarding some discussions there was on Stack Overflow regarding this, which were quite interesting to read. So finally, what was the conclusion? Well, I would say so. It was just a quick overview in a few minutes, and in my personal opinion to that is that, as I mentioned before, readability is the most important value, at least for me. So if using the rule makes the code clearer and more understandable and readable, I would definitely go for it. If the other thing, if it is not the case, so if applying the rule, like in the example, make the code harder to understand, I will not use it. So it's up to you to apply it or not. I would say if it makes sense, do it. If not, don't. So that is it. And thank you for attention.
Thank you, Miroslav. And the next speaker is Christopher. So here we go. Christopher, you're ready? Then we can go. You need to unmute yourself.
Great, that was the last thing. Okay, so in today's world, we have C++20, and C++20. One of its features is boasting modules. Unfortunately for us, the majority of the world does not use C++20, and it will be some time before we can use C++20, which means that the majority of code is going to be unable to use modules. This is also problematic because even once code moves to C++20, that does not necessarily mean that we will be automatically using modules. For modules in C++20, we would need to do something like import std, and that would get us the stuff. But up until C++20, we've had to dutifully write hash include utility, hash include vector, and so on. And so that means that unless implementations will provide us with what are called header units, which are a map, it was just sort of like a bridge from headers to modules, then we don't get this feature just by flipping a switch. Now, the standard library will definitely provide these header units, and libc++ already does this for Clang. I wouldn't be surprised if libstd++, the GNU implementation, does it for GCC, and MSVC's STL does a similar thing for MSVC, but this doesn't necessarily propagate to third-party libraries. And so we still have a bit of a problem, and it'd be nice if we could get some of the functionality of modules today. So one thing that we can do is, if we're on Clang, we can actually already start to take advantage of this idea of header units, which starts to treat headers like they are modules today. And the way in which we do this is by enabling the F modules flag, and that will give us module-like functionality. For example, this is a test case, a test suite that checks the casts in utility for forward move as const and a couple of the others. Now, something that is not in utility is fputs. That's in cstd.io. So if I were to do std puts and then say hello meeting C++, and then I were to run what is the name of this test? It is just casts. Okay, so if I were to run Ninja casts, and it builds. However, if I were to be using modules, then it would have said no. No, you can't be. Oh, right. Okay, I understand what's going on. It's because this one is a special header. So I need to pick something else, such as perhaps an iterator. Why don't we pick something? Let's just double check what's in test. And so we can see that there is a cstd.io. And so this is just a traditional header that will be like a copy paste. And so this is not necessarily going to be a beneficial thing for us, because we're still getting the preprocessor working when a header is treated as a textual unit. But let's now pick something that isn't mentioned in this list of things. From this list, we can see that a bunch of them are C headers followed by type traits and concepts. So as long as we don't pick one of those, then we should be good. So let's now go back down here, and we will say auto I equals stirred input iterator tag. That is a good one. And so if we look over here, we see that we get the traditional error of no member named input iterator tag in namespace stirred fix available, and that fix would be to include iterator. However, that's the pre-process. That's what's happening in without the modules enabled, because Clang D doesn't work well with modules, so I have turned off that feature. However, if we were to compile it now, I need to Ninja. Oh, I haven't saved. That's the problem. If I now do this, we will see that there is no member name this, and we still are not getting what we want. So what we can do is we can look at the at this file inside the standard library called a module map, and the module map is basically a way of saying this this thing is going to take this file and map it to a particular module, and this is how we can say build up a set of header units. So what we want to do is we want to make sure that sorry, pardon me. We want to make sure that the module has all the things that it needs in order to build this thing out and treat it as if it were a module. And I do not see the thing in here that is necessary, so we can change this again to incrementable, and then we'll say auto x equals 2, and we will also just do this. And again, we can see that there's no incrementable in namespace stirred, and we can build this again. And okay, I've named it X, which is the problem here. Y, and we'll try that again. And it gives us the same error. So I'm going to have to end this here. But the main idea is that with Clang modules, header modules, we can compartmentalize things. And thank you for your time.
Thank you, Christopher. That was interesting. Let's go ahead and bring Kilian back in the stream. Yes.
All right. Thank you very much, Jens. Welcome everyone to 75 SDL letters in under 10 minutes. So I would say you make yourself comfortable, lean back, fasten the seatbelts, because we are about to get started. Algorithms. This header contains computer science algorithms, which mostly operate on a sequence of elements. And since C++20, this sequence of elements does no longer only have to be provided as a pair of iterators, but can also be provided as a range or as a pair of an iterator and a sentinel. We've got the any type, which is a type erasure wrapper for any copy constructible type. We've got array, which is a wrapper around a C-style array and provides a container API as well as better type safety than the C-style array. We've got atomic, which is a class template that you can instantiate with any structure layout type, and then it provides well-defined concurrent access from multiple threads. We've got the barrier available in C++20, which is a reusable thread barrier that blocks up to n threads, and when the last thread arrives, the completion function gets executed and the barrier opens again. We've got bit, which contains an enum endian to query the endianness of your hardware, and as well as several functions to access, manipulate, and process bits and bit sequences. We've got STD bit set, which is a fixed size sequence of n bits that you can manipulate and access. We've got charconf, which provides conversion functions between character sequence and either a floating point or an integer. We've got chrono, which is the date and time library of C++. It mainly consists of clocks, time points, and durations. And since C++20, we also got calendar types and time zones. The compare header provides library support for the three-way comparison operator, also known as spaceship operator. In complex, we've got complex number support. Concepts define some common concepts that are used throughout the STL. Condition variable is a synchronization primitive that can block a thread until it gets notified and some certain condition is verified. Coroutine provides library support for coroutines, as well as the class template SCD coroutine handle, which is a non-owning handle to the actual underlying coroutine that the compiler generates for us. Deck is a double-ended queue. Exception provides the base class SCD exception, as well as the terminate handler. The exception pointer, which is some type-erased shared pointer type to store any exception object. And we've got library support for nested exception. Execution enables us or provides us with policies to concurrently execute algorithms. The file system gives us the possibility to access and manipulate files, directories, and paths. Format is a text formatting library, which is type-safe and also extendable by specializing the class template SCD formatter for your own types. Forward list is a single linked list. Fstream provides a basic stream buff as well as I/O streams to do file I/O. Functional provides function objects to do arithmetic and comparison, like plus, minus, less. It provides a standard hash function. The type erasure wrapper for any callable object called SCD function and other. Future provides types and functions related to asynchronous tasks. For example, you can query or wait for a future or shed future to get some result that a promise can set in another thread. Initializer list is a view of a constant array that gets brace initialized. IO manip provides view manipulators that are invoked with arguments, and as well as the function SCD quoted. iOS provides stream manipulators that are invoked without arguments, and it contains the two base classes for streams and working with stream buffers. We've got an iOS forward declaration header. iostream provides the 4 global objects, cout, cr, clog, and cin. iStream provides the high-level streams for reading and both reading and writing. Iterator provides tag types and concepts for 6 kinds of iterators, provides iterator traits, and as well as adapters like a back inserter and utility functions to work with iterators. Ledge is like SCD barrier, but it's a single usage thread barrier, so it can only be reached once. Limits provides a class template SCD numeric limits that can be instantiated with fundamental numeric types, and provides options to query properties like the minimum value, maximum value, and so on. SCD list is a doubly linked list. Local provides access to cultural differences like character classification, number formatting, and can be also overwritten by the user. We've got 2 kinds of sorted maps of key value pairs. SCD map, where each key can appear at most once, and multi-map, where it can appear multiple times. We've got a memory management. We've got a memory with the memory management support. Smart pointer, 3 different kinds of those, and also atomic support for shared pointer and weak pointer. We've got the allocator traits to access an allocator, and pointer traits to access pointer-like types, and some utility functions to work with your raw storage. We've got memory resource, which contains the SCD PMR polymorphic allocator, which is an allocator that wraps a polymorphic SCD PMR memory resource. And there are also 3 concrete predefined memory resources, synchronized and unsynchronized pool resource, as well as monotonic buffer resource. We've got the mutex header, which provides synchronization support by mutual exclusive access. We have several different mutexes, and we have some AII locking classes as well as variadic functions to do the locking and avoid deadlocks for us. We've got some low-level memory management in the header new, for example, the new handler, as well as overloads of operator new and delete, including some taking node throw, align val, and destroying delete. We've got mathematical constants in the header numbers like pi and e. We've got the numeric header, which provides numeric algorithms that also work on a range or sequence of elements, but we also got GCD, LCM, and midpoint. We've got optional, which is a wrapper around some type T, which either holds the value of the type T or is empty. We've got OStream, which is a high-level facility to write to a basic stream buff, as well as some output manipulators. We've got the SCD queue, which is a container adapter, which represents the first out, first in queue, as well as priority queue, which also takes a comparator such that the underlying container is sorted with respect to the comparator and represents a heap. We've got random to generate random numbers. The randomness comes from some uniform random bit engine, which first where it produces a randomness, and based on this we can have a distribution, like a normal distribution, Bernoulli distribution, which then generates a random number. We've got the ranges libraries in C++20. It heavily relies on concepts, for example, range, bold, range of view. Then we can have some range factories like view single or Yota, and most importantly probably are the range adapters where you can take a range and pipe it into, for example, a filter view or reverse view. We've got STD ratio, which takes a numerator and a denominator as compile time arguments and then provides some compile time arithmetic comparison. We've got predefined type defs like microcenti, which are also used in the Chrono library. We've got a regular expression library. Scope allocator provides the scope allocator adapter such that you can have a multi-level allocator which you can plug into a multi-level container like vector of list of set of string or something like that. Semaphore provides a counting semaphore, which is a synchronization primitive that controls access to a shared resource like a mutex. But other than a mutex, you have some counter n, which gives the maximum amount of threads that can access that resource simultaneously. We've got two kinds of sorted sets. The STD set ensures that each value or key appears at most once, and a multi-set can appear multiple times. We've got a shared mutex header, which provides both mutual exclusive access, but also shared access, depending on whether you call log or log shared. The source location describes a source in your code, containing also a file name and a function name, and the magic lies in the static member function current, which gets evaluated at the call site and gives you a meaningful object of type source location. We've got a span, which is a non-only view over some contiguous sequence. We've got stream, which contains a stream buff as well as IO streams to work on strings. We've got stack, which is a container adapter that represents the last in, first out stack. We've got std except, which defines some common exception types that are used throughout the STL. We've got stop token, which provides thread cancellation mechanisms. So you have a stop source where at some point you can request a stop, and then you can have several stop tokens which continuously poll whether a stop has been requested and then do some certain action based on that. Stream buff is the base stream buffer class that we have, which controls input and output to some character sequence. Where we've got our std string. The string view is a read-only view over some contiguous sequence of characters. Sync stream is a synchronization mechanism to synchronize the output to some outstream, for example, cout. System error provides some low-level error codes as well as the exception type std system error, which then wraps an error code. We've got std thread to start a new thread of execution, and in C++20 we also have the joining thread, which joins automatically and can also be cancelled, and we have the namespace std this thread to access the current thread. We've got std tuple as well as some helper function for it. We've got std type index, which is a wrapper around std type info and provides a hash as well as being copier, which makes it easier to use in containers. std type info is the RTTI of some type and the result after calling type ID. Type trace provides some metaprogramming facilities to inspect and to transform types at compile time. We've got two kinds of hash maps of key value pairs, std unordered map, where each key can appear at most once, and std unordered multimap, where it can appear multiple times. We've got the same for hash sets, basically. Utility provides a pair as well as integer sequence and some utility functions. We've got a numeric vector called val array. We've got a variant, which is a sum type that stores a value of one of the types we specify in the template argument list. We've got our vector or dynamics contiguous array. And last but not least, we've got versions in C++20, which provides some feature test markers where you can check whether certain features are available or not. Thank you very much.
75 indeed. That's interesting. Thank you. Yeah, thank you, Kilian. That was really interesting. Which brings me to Soren. And Soren, your slides are live. We are ready to hear your talk. Please unmute.
Kilian, can I get you to mute your mic again? Thank you. Yeah, I want you, hi, meeting C++ Online. I want you to make error handling your user's problem. It turns out they may thank you for it. It says will. Users are ungrateful sometimes. They should. This is inspired by Bandin's now 6-year-old talk, Using Types Effectively, and by a problem I had at work some time ago now. But the very short version of it is you should write some total functions because they're easier to understand and they're easier to write. And I have some very bare bones examples. I'm sure you can extrapolate them to your own work. But let's say we want to count some vowels in a text string. It's not hard, except what's the return type here? What if they hand us a null pointer, right? We can't necessarily just always give a good answer. You could say that there are no vowels in a null pointer, but you could also say that a null pointer is not a string, like it's not a string of chars. So what do? Do we throw an exception? Some people hate exceptions. We could make auto a pair, right? We've seen this one before, or it could be an output value or anything. Or we could just throw up our hands and say to the user, actually, you know what? If you give us a null pointer, that's UB. Like, just don't do it. There's a precondition on the input that you don't hand us a null pointer. Or you could just use a string view. Obviously, if you're in some very special case where you cannot use a string view, or if your code space is old enough, then write your own string view if it's not in the standard yet. But you can just use a string view. The return type is a size type, or it's an integer if you want it to be. But the point is, it's not in doubt. Like this function is so easy to implement that it's almost embarrassing to talk about it. Like, implements itself. There are no weird edge cases with the string view, solid return type, and the users don't need to read the documentation for count vowel. Like, you can see that single line of code returns a size type, takes a string view. I know what this function does. I don't need to read any documentation. Now, this is a simple function, but what if I don't need to read any documentation for other functions? So, string views in the standard. Let's take a different example. The reciprocal, the inverse of a double. I mean, we want to write it like this. Like that's what we want to do. But of course, that's not how doubles work. Doubles aren't real numbers, really. We have a bunch of preconditions. Each of these preconditions, you could write them in the documentation. The user's going to have to find out how this function works somehow. Does it throw? What does it do? Who knows? But you should solve this problem exactly the same way, right? You shouldn't take a double. You should take a divisor. Divisors as a class, you write it yourself in 5 minutes and handles all of this. So the function has no room for error anymore. What if the user has a 0, though? What if they try to construct the divisor with a 0? That's what I mean by you should make the error the user's problem. Obviously, if your user can use exceptions, you write divisors so the constructor throws. Dead simple. But if you don't, the private constructor, right, have a static function in the divisor that gives you back an optional divisor. Or if you don't like optional in your code base because it's C++ 11, write your own optional. But either way, your actual function, reciprocal, is dead simple. Now, this does have a problem, because if you take every single input parameter that you have in all of your functions that currently throw or return errors, and you write classes for them, I have some sad news. There's nobody who wants to read all of the documentation for a whole new class for every input parameter. That's gonna get old. But if you adopt this approach, also, of course, consider adopting a framework. Do something like this. The user, this is the CPP file. Using divisor, that line goes in the header file along with the function signature, so the user can see what it is. A divisor is a constrained double. It's not 0, and it's finite. And if you're not familiar with the CMath library, finite means it's not nan, and it's also not infinite. It covers both of them. So I guess you have to know your standard headers to know what this line of code means. But the great thing about this is that it shows the user right here without having to go anywhere to read documentation, what the constraints are on a divisor. You're going to have to write the constraint class yourself, and your user is going to have to understand it. But once they understand the constraint class in one place, then when you use the constraint class in a different place, they don't have to read it again. It's just a set of constraints. And if you name your constraints well, you can read them all on that line, see exactly what the requirements is for a double that wants to be used as a divisor. So, concluding really, you should enforce your preconditions with invariants. It makes your functions much better. It also lets your users select their error handling, because if they can't handle exceptions, you can just, in your class that handles your parameter, not use exceptions. It's all been pushed out. And instead of writing and documenting a lot of parameters, you should consider using a framework to save time. That's really it. I wrote a framework like that earlier this year. It's fantastic. It's going open source in a very short while. But if you want to have something in-house, write something in-house. It's not very hard. And it solves a lot of problems.
Hi. Thank you. That was interesting. Thank you, sir. Now, oh yeah, right. I have also prepared a talk. So I've been looking into charts and how to do charts in Qt, because Qt is what I use for UI. And if you follow me on social media and other ways around, happen to have spent some time with my platform, you probably know that I like charts. And on the one side, you see the most recent chart I created, which is data from the job fairs. And I was wondering if we can have some population data on the percentage of what people submitted or identified with, that'd be great. And that's the graph. Some of those graphs have really been a modern work of art. And then I have graphs for some time now in the survey, which are bar charts. And the new type is a line graph. And for the line graph, what makes line graphs for me more difficult is you need to have a lot of data points from something that is interesting, and multiple of them probably to make that worth looking at. But so how do I get those charts into the Qt application? That's for me one of the things I was thinking about. And I did some research. There's two ways. You can go the QML way, and you can go the Qt charts way with C++. Qt charts is a Qt extension. It's under GPL and commercial license, either if you use it as QML or as a Qt charts. And that is the way that ships with Qt, where you can, draw your own charts and put out your charts in QML. But there's an alternative, which I found, which uses on QML chart.js, and it's MIT licensed. There are, of course, also some other ways. You could use a web view, but that's bringing in Chromium in your application. That's a little bit too heavy, so I'm not going that route. So the way to use QML and not use Qt charts and have an MIT chart library in your code base is this, which I could find under GitHub. And it looks kind of nice at the first glance. It uses an old version, 2.93. The 3.0 branch of chart.js uses web workers, and web workers are not supplied in chart.js. Web workers are not able to run in QML. That's the issue. It's MIT licensed, and with the usage, I still have to play around with it and actually make an application that gets data from C++ into the graph. So actually, importing actual data in the graphs is, for me, still a question how that really works. And the advantage for me is like there's a QML widget, and so it also would be working for QWidget-based applications. If one can find out a good way to have an API to get data into the graph from C++. And also, let's have a look at QCharts. QCharts draws really nice charts. It's no way less or better. It's equal to the other chart solution, maybe a bit better. It uses a graphics view, so it's more natural in your application if you use C++. You need to install it from the maintenance tool. And if you have commercial licensing for Qt and with your employer, you can use it. It's there. Otherwise, you will have to face that this library is for the open source world under GPL, which might not make your employer too happy. And also how I learned when I looked at the QML example that if you use it in QML, you need to exchange your Q GUI application instances for Q application instances, because that is a dependency which you get with graphics view framework, which internally is used to draw those charts, which I would have never guessed that this is the case without reading this disclaimer. So sometimes it pays to read the documentation now. And this is a small example which I've written with QCharts today. It basically has a button and it has a chart view, and this chart view has a chart, and then I just use in this part a line series which I generate and append to the chart and then add series in. So I have 3 different lines with random numbers being displayed, and it's really fun to click on a new chart and see just new lines coming up. And yeah, let's make that a bit bigger that you can see the code actually. That's fairly easy written code to have some charts in the application. But what about the GPL again, right? What if we could contain that to its own executable? I think that's actually a neat idea to have a Qt chart server. There's a TCP server class in Qt, which I have never used, and I finally find a useful and small contained example where I could put that to use. So in one usage example, you would have the client send a chart request, and probably prior to that start the server if it's not running. And the server then would probably need to be a GUI application, because those charts need to be drawn, and I think that needs to be in a GUI interface and also in the main thread, I think. And then you get the response, and the response would be telling you that your chart is ready, but also either that would be JSON containing a binary like a base 64 encoded string, or the chart request took the other route and telling the server to write, because it's running on localhost, to write it to a file, to a JPEG file or a PNG file to be used. Because some of my use cases, I would rather have it as an image I could post to social media or use in a blog post than to use this in some other manner. And this client would, be responsible for creating the chart data objects, with filling it with the data and writing these to JSON. Also needs the size of the graph. If you have an image, or if you have like a window, you probably have a size which you might want to be bigger than that to scale it down again, and all those things. That's something which needs to be handled by the client, and then you send it to the server, and later the client's job is also to notify the application that your chart is here. So right now there's 2 ideas which are probably both fairly easy to implement, which I'm currently thinking about when, and that's probably going to be winter. And so with the QML example, I'm not sure if it's still working with Qt 6, because this code is like 3 years old. and the chart.js is also kind of old. So the newer chart.js examples which you find on the web are useless. So that probably is some work to get running. On the other side, writing a server application sounds like fun, but in the actual environment to get this to run with other applications and having this run in the background, I don't know if that's like on the long run a good idea. So charts are not lightweight. It's dragging in JavaScript and QML to have some charts is nice, but it's not going to make your application lightweight. Same thing with like having a full-blown server application running in the background to have charts. The server application would have the advantage to, when you have several applications running at the same time, you would have only to run one server and you'd be fine. And otherwise, you'd be having to, have running this code again and again in your applications. But that's probably in today's environment fine. If you're not like an embedded, but who wants to have a chart in embedded, right? And that brings me to the end. Thank you for listening. And also thank you for everyone else who has contributed to today's meeting with Lightning Talks. And we're going to move over to Vido now and see who of us will be there. And then we'll have a panel there to start the Q&A panel on the Lightning Talks.